Now, subscribe to Bright Duty course at ₹1 per day only. Download Bright Duty app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Duty courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Duty follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tuesday and avail your courses at affordable prices.
Process of getting your original data back. Now there you also saw one more new terminology called cipher. Okay, cipher is nothing but is the key. Okay, as I told you, whenever you want to encrypt a message, you need to add a key to your original message. Only then it can be encrypted. So that key is called as a cipher. Okay, it is also nothing but a virtual lock. Okay, it can be considered as a virtual lock. So today, what we are going to do is we are going to see how a message can be encrypted using Cipher's cipher. Okay, has anyone of you heard about Cipher's cipher before? Anyone? No. Okay, so Cipher's cipher is nothing but, see, this encryption and decryption is not something new. Okay, it has started many years before. And in fact, you must have heard about Julius Caesar, right? He was one of the Roman general. Okay, so during the World War, what he did is he used to, in order to communicate to his, people, he used to encrypt the messages and send it in a paper. So what happens, even if the enemies get the paper, they would not understand what is the message. Okay, but the key has to be decided from the sender and the receiver, what key he has used to encrypt. Only then the receiver can use the same key and decrypt the message. So this is something that was practiced thousands of years before. Okay, so let me just show you one more video on how the Cipher cipher is used, and then we will start writing the program, because you need to know what exactly this, what is this virtual lock or what is the cipher. So that when we're doing the program, you will have a better idea of it. Okay, yeah.
The first well-known cipher, a substitution cipher, was used by Julius Caesar around 58 BC. It is now referred to as the Caesar cipher. Caesar shifted each letter in his military commands in order to make them appear meaningless should the enemy intercept it. Imagine Alice and Bob decided to communicate using the Caesar cipher. First, they would need to agree in advance on a shift to use, say 3. So to encrypt her message, Alice would need to apply a shift of 3 to each letter in her original message. So A becomes D, B becomes E, C becomes F, and so on. This unreadable or encrypted message is then sent to Bob openly. Then Bob simply subtracts the shift of 3 from each letter in order to read the original message. Incredibly, this basic cipher was used by military leaders for hundreds of years after Caesar.
I have fought and won, but I haven't conquered over man's spirit, which is indomitable.
However, a lock is only as strong as its weakest point. A lock breaker may look for mechanical flaws, or failing that, extract information in order to narrow down the correct combination. The process of lock breaking and code breaking are very similar. The weakness of the Caesar cipher was published 800 years later by an Arab mathematician named Al-Kindi. He broke the Caesar cipher by using a clue based on an important property of the language a message is written in. If you scan text from any book and count the frequency of each letter, you will find a fairly consistent pattern. For example, these are the letter frequencies of English. This can be thought of as a fingerprint of English. We leave this fingerprint when we communicate without realizing it. This clue is one of the most valuable tools for a code breaker. To break this cipher, they count up the frequencies of each letter in the encrypted text and check how far the fingerprint has shifted. For example, if H is the most popular letter in the encrypted message instead of E, then the shift was likely 3. So they reversed the shift in order to reveal the original message. This is called frequency analysis, and it was a blow to the security of the Caesar cipher.
Okay, so that was about, you don't have to go in depth about what it is. I just showed you that video so that you know.
A strong cipher is one which disguises.
So I just showed you that video so as to get a better idea. See, now Caesar cipher is nothing but you're shifting the alphabets. Okay, if you're saying key is equal to 5 means you're shifting the letters, and then you will get a new set of encrypted letters. Okay, I'll just show you an example. Okay, so you can, for example, now if I say, can you see this? I have like 2 concentric circles over here. Okay, in the innermost circle, I have A, B, C, D till Z. Okay, or Z, whatever you want to call it, is written. And you're giving numbers, you're allocating numbers to the letters starting from 0. It can be either from 0 or either from 1. So if A is equal to 0, B is equal to 1, C is equal to 2, it goes on till Z is equal to 25. Okay, now when I say I'm going to add a key of 3, okay, that means what? I'm going to basically shift. Okay, I'm going to shift the new value of A will become 0 plus 3. So what is 0 plus 3? It is 3. So what happens is the new value of A, okay, will become 3. So I am turning my outer circle. Okay, see, I'm turning my outer circle and I'm placing A at 3. Okay, similarly, B is initially initialized to 1. Okay, when I add the key to B, okay, it becomes 1 plus 3, so it becomes 4. So the new value of B is 4. Can you see on the screen? I hope you can see on the screen, right? Unable to understand, see, you don't have to go in depth of this. I'm just trying to tell you this so that when we write our code, you will get a better understanding. Okay, so now the new value of A is 3, the new value of B becomes 4, C becomes 5, and so on. Now say, for example, I want to encrypt the message hello. Okay, HELLO. Okay, I want to encrypt this. So what happens is inside the circle, you see H is having the value 7. Right now, after I encrypt, after I add the key, okay, what is the new value of H? Okay, what is the new value of H? It becomes K. So H is replaced with K. Are you understanding? Next, E is 4. But after you add the key plus 3, the new value of E is H. So E becomes H. Okay, E becomes H. Again, you have L. L, the original value was 11. After you added the key, okay, the value of L becomes O. This is L here. It becomes O, 14. Okay, another HELLO, another L, so another O. And then O is 14, but the new value of O becomes R. So HELLO will be encrypted as KHOOR. Okay, that's what I just wanted to show you here. Have you understood this? Yes? Onto the chat, yes or no? Okay, it is a little confusing, but you know, just try to understand this. Today we are just going to write a program to encrypt a message. So before that, and then so I just wanted to show you the basics of how this encryption works. Encryption always works when you're adding a key to the original message to encrypt it. Okay, so that is what I just showed you an example. Okay, now let us write a Python program. So now let me go to, today I am doing this program on idle because, you know, in Trinket, the screen is really small. So, you know, it is difficult to scroll up and down. So I thought of doing it on idle. So you can log into Trinket and you can start doing simultaneously, please, because I will not be able to share the the code or the file with you. So just do it simultaneously, and I'll be explaining each and every step. Okay, so I hope you all are ready. Okay, and this is, please pay attention, because this is a little like confusing, but once you know how it is working, then you can do it. Okay, fine. So now let me take a new file. I don't want to do it on shell, so I'm going to take a new file. All right, and let us start with our program. So first, what I'm going to create is the size is increased only, so I have increased the size. So first is I'm going to take a variable called alphabet. Okay, so I'm taking alphabet is equal to, I hope the font size is fine, right? You are able to see it? Yes? It is not notepad, I'm doing it in idle. You don't have to download this. As I told you, please, you can work on Trinket. The reason why I am using idle is because the Trinket screen is really small. So what happens is, I have to keep scrolling up and down many times. So that's the reason I thought I will do it in idle. Okay, so you can do it on Trinket. Those are having idle already installed, you can do it on idle. Okay, Python, not Python 3, it is on Python. Go to new Trinket and take Python. Okay, not Python 3, because if you take Python 3, you cannot save your file. So take Python. All right, so first I'm going to create a variable called alphabet, and inside this I am going to write my alphabets into this. Okay, so I'm going to say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. All right. Okay, so you're going to increase the font. Are you not able to see? Yes? Yes or no? Should I increase the font a little more? How about now? It's still the same. Okay, so let's now go. Okay, now I have created my variable alphabet, wherein I am having all the letters of my alphabet, A to Z. Okay, now as I told you, double quotes or single quotes, it can be anything. String can either be represented with double quotes or single quotes. Okay, now as I told you, in encryption you always need to add a key to your original, okay, to your original data in order to encrypt it. So let us take the key as key is equal to 3. It can be 3, it can be 5, it can be 10, it can be anything. Okay, so since we have already seen an example with key is equal to 3, let us keep it as 3 itself. Okay, now next is what I'm going to do is, we are going to ask the user to input a message. Okay, we are going to ask user to input a message. So I'm going to say message is equal to input, enter a message. All right, input a message. So we are going to ask the user to input a message or anything, a word or whatever it is. Okay, so now this message, whatever the user has entered, we have to encrypt this. Okay.
Now, subscribe to Bright Duty course at ₹1 per day only. Download Bright Duty app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Duty courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Duty follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. in exam preparation. Previous year's question papers, sample papers, and model test papers are available with the solutions. Sign up today on Bright Tutor and avail your courses at affordable prices.